assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Alright, in this problem, we are given the scenario that we have a car that has a mass of 1,000 kilograms, and inside the car are 4 people, each with a mass of 82 kilograms, so a total of 328 kilograms. And it's traveling down a dirt road that has corrugations that are 4 meters apart. And it is also given to us that the car bounces with its maximum amplitude when its speed is at 16 kilometers per hour. Now we know the distance between the two maximums is the distance traveled during one period, and since the speed during this period is our velocity, then we can actually use the equation t equals our velocity divided by our distance between. We're also going to use the equation omega equals the square root of k divided by our mass, but in this case we need to have the mass of our car plus the mass of our 4 people in the car. And we can also have the equation that omega equals 2 pi over t. So putting all of these together, we actually will use the equation 2 pi v over d equals the square root of k divided by the mass of the car plus the mass of the people. And we're going to solve for k. So in this case, solving for k, we would have the equation mass of the car plus mass of the people times 2 pi v over d squared. Okay, so now thinking about the displacement, the vertical displacement of the car initially is the force of the mass and the force of gravity. So we have our force initial is going to be kxi, and here force is the force of gravity, and initially the mass is the mass of the car plus the 4 people, so we can also write this as force initial equals the mass of the car plus the mass of the people times gravity, and we can make that equal to our kxi, and solve for xi. So taking this equation right here, this part, and solving for xi, we have xi equals the mass of the car plus the mass of the people times g divided by k. So this is our displacement when the people are in the car. We also need the displacement when the people are out of the car. And so in that case, we have our force is actually just going to equal the mass of the car times gravity. And we can again make that equal to k times our displacement, although this will be our final displacement. So this is our final force, and it's going to be our final displacement. And solving for xf, we get xf equals the mass of the car times gravity divided by k. So to find the difference between the two, we are going to do the difference between xi minus xf, which is going to be the mass of the people times gravity over k. And now we can take this term up here that we created for k and substitute that in. So we will have the difference between our xi minus our xf is going to equal the mass of our people times gravity divided by the mass of the car plus the mass of the people times the distance between the corrugates divided by 2 pi v squared. And we'll start substituting in our known values. So xi minus xf is going to equal the mass of our people, which was 328 kilograms. So 328 kilograms times 9.8 divided by the mass of the car, which was 1,000, plus 328 kilograms for the people, times 4.0 meters divided by 2 pi times 4.44 meters per second, which gives us a total difference of 0.050 meters. So the vehicle will rise 0.05 meters when the people get out.